So good evening friends. Today we are going to discuss how MapReduce works. Okay, so in that process I would like to start with a pseudo distributed mode. So let me just recap what exactly is a pseudo distributed mode. In case of pseudo distributed mode, you will have one single system, one Linux box. Okay, assume that this is a Linux box. Which one? Let's say Ubuntu Linux box. Okay, and we have installed Java here, we have installed Hadoop here. Okay, and we started our Hadoop cluster. So here when I say cluster in pseudo distributed mode, that means only one system. Okay, so in case of pseudo distributed mode, you will have only one Linux box where your Hadoop will be installed, and all the Hadoop demos will be running on the same system. Okay, so check it out here. In this whole system, name node will run, secondary name node will run, job tracker will run, task tracker will run, as well as data node will run. Okay, now let's say we have given a command like this. Hadoop fs put slash home slash Suraj slash abc or let's say word count.txt word.txt. Okay, slash hd user slash data word.txt. Do you understand this command we had discussed yesterday? Do you remember this command? What it will do? Yes, tell me what it will do. This command Hadoop fs put. It is basically used to copy the file. It is basically used to copy the file from your local system to Hadoop system. Is not it? Similarly, we have a command called get. Hadoop fs get slash sd user slash data word.txt. I want to get that into my local system slash home slash user okay data slash let's say word.txt. So the first command is basically to write the data into SDFS. The second command is basically to get the data from a Hadoop distributed file system. Similarly, we have something called Hadoop jar. Okay, this is used to execute the MapReduce program. This command is used to execute a MapReduce program. Hadoop jar space your jar file name which contains MapReduce program, my word count dot jar. Okay, now input path where your data is available, SDFS input path. Okay, next space SDFS output path where you want to store your data. Okay, so this third command will actually do what? It will run the MapReduce program on which data? On the data which is available in this input path. Are you clear? Okay. Now when I write this when we write this Hadoop jar word count dot jar, when we write this command Hadoop jar word count dot jar input path output path, so when we submit this job, who takes care of that job? In the master, who takes care of that job? Yesterday we discussed that. Yeah, job tracker. So whenever you submit that job, that will directly go to job tracker, right? That will directly go to job tracker. And then what this job tracker will do, it will give that to whom? It will give that job for execution to whom? Data node contains only data. It has no capability to process the data. So when you give the job, when you submit your job, it goes to the job tracker. The job tracker will then give it to task tracker, is not it? And the task tracker will start processing that data which is maintained by the data node. Right? So in this pseudo distributed environment, can you tell me how many JVMs are used for this Hadoop cluster? One or more than one? This is pseudo distributed. This is not local mode. We discussed that there are three different modes in Hadoop. One is local mode, one is pseudo distributed mode, and another one is fully distributed mode. So this is a pseudo distributed mode. How many? One or more than one? Come on, I think you got confused. In case of local mode, only one JVM will be used for all these daemons. Name node, job tracker, task tracker, data node, secondary name node. All this will work on the same JVM. But in case of pseudo distributed, although the box is same, although the Unix box is same, operating system is same, but they will use multiple JVMs. Clear on this? So this name node will run on one JVM, this job tracker will run on another JVM, this task tracker will run on another JVM, this data node will run on another JVM, this secondary name node will run on another JVM. Okay, now where exactly the processing will take place? Job tracker or task tracker? Correct, task tracker. So this task tracker, okay, will not directly process the data, but what it will do, it will create one more process called task instance. Okay, it will create one more process called task instance, and this instance will also run on different JVM. Okay, this task instance will also run on different JVM. Now inside this task instance you will see two slots. Okay, you will see two slots. These are two different slots. So you will have map slots and you will have reduce slots. By default when you don't disturb the configuration, you will get two map slots, okay, and then you will get two reduce slots. Alright, so all this thing will be controlled by your task tracker. This will be controlled by your task tracker. Okay, I repeat, whenever the user submits a job, that job submission will be taken care by job tracker. Job tracker will give that to task tracker. Task tracker is responsible to execute the job, but it will not do the execution. Instead of that, it will create one more JVM, we call it task instance, and in this task instance you will see two slot, map slot and reduce slot, and by default you will see two map slots and you will see two reduce slots. So we say map reduce, right? So all the mapping activity will be taken care in the map slot, all the reducing activity will be taken care in reduce slot. Are we clear on this? Okay, now let's take one example. Okay, let's take one example. Let's assume that I have a big file. Right, let's assume that I have a big file of, here some data are there. Okay, I have a big file of, let's say 300 MB. Okay, my total size of the file is 300 MB. And what is the default block size in case of Apache? 64 MB, correct. So the default block size is 64 MB. Now the data will be divided into how many blocks? The whole data will be divided into how many blocks? Let's check. I'll say Control L, calculator, 300 by 64, 5 blocks. Block 1, block 2, block 3, block 4, block 5. So let's say the block 1 size is 64, the block 2 size is 64, block 3 size is 64, block 4 size is 64, block 5 size is Control R, 44, right, MB. What is the default replication factor? 3, correct. So now in this example, let me not discuss about replication factor, okay, because I'm just trying to give you an example with respect to a single node. Let's assume the replication factor is 1 only. Okay, we have configured to 1. So how many copy will be maintained? Only 1. So who takes care of all these datas? Which daemon takes care of this data? Data node, correct. So in the hard disk somewhere you will see block 1, block 2, block 3, block 4, block 5. In the hard disk you will see block 1, block 2, block 3, block 4, block 5, and all these are maintained by your data node. Okay, now let's assume you have submitted a job. You have submitted a job, Hadoop jar, your jar file name, input path and output path. In the input path you have given the path of this file, the place where this file is present in your SDFS. Okay, so that will go to job tracker, and the job tracker will give that assignment to task tracker. Now in the task tracker, the task tracker will know that this particular file, okay, was of 300 MB and it is available in form of block 1, block 2, block 3, block 4 and block 5. Is not it? So the task tracker will hand over that work to task instance. Okay, the task tracker will hand over that job to task instance. Now in the task instance, how many map slots are available? 2. Okay, 2 map slots are available, but how many block we have now? 5. So how many will be processed, 2 or 5? what will happen is initially 2 will be processed. Okay, see, one block will be processed by only one map slot at the same time. Okay, so first time block 1 and block 2 gets processed. Okay, assume that block 1 and block 2 processing is completed. Then block 3 and block 4 will be processed. Okay, now assume that block 3 got over, whereas block 4 is still processing. So what will happen? Again block 5 will be processed. Getting my point? So let's assume these two are the map slot, map 1 and map 2. Map 1 is processing block 1, map 2 is processing block 2. Both of them have completed the work, or uh, one guy has completed processing. So what will happen? He will start processing another block. Okay, again when this slot get the processing done, again the task instance will assign one more block to it. Are you getting my point? So since we have only two blocks and we have many, since we have only two slots and we have many blocks, so they will start processing the data, but few blocks will be processed at the same time and the remaining block has to wait for its turn. Getting my point? Okay, now assume that this is the data which is present here, and this data contains some problem due to which you got array index out of bound exception or one or other exception you got. Okay, so when you get exception in your program, your program will your JVM will survive or your JVM will die. When you get exception in your Java program, your JVM will survive or your JVM will die. You might have experienced while writing Java code, when you make any mistake due to which you get some sort of exception, let's say file not found exception or whatever exception, so your program will be terminated or your program will continue if you don't handle it. The program will be terminated. So this task instance, okay, this task instance is working on your file and there is some problem in your file due to which one or other exception got created. So due to which what will happen? Task instance will be terminated or not. Yes, the task instance will be terminated. Okay, so since you got exception, your task instance will be terminated, but still your task tracker will not be terminated. Are you getting my point? This will be terminated, JVM will be terminated, JVM2 will get terminated, but still your task tracker will not be terminated. That is the reason they are working on two different instances. They are working on two different JVM. Suppose they would not have introduced the concept of task instance, and suppose all this processing would be taken place in task tracker itself, then what will happen? The moment you get any problem in your data or in your program, okay, and the program gets terminated, then your task tracker will be terminated completely. Are you getting my point? So now let us discuss the same thing in a cluster, which will make you more clear. So here we have the same file. I will copy the data. Copy this. Okay, let's talk about the cluster now. Okay, now in this cluster, if you see, we have a master, right, and we have sleeps. Okay, so here I have 5 blocks altogether, 5 blocks altogether, and let's say the replication factor is 3. Let's say the replication factor is 3. So the block B1 will be copied in 3 different places, is not it? Block 1 here, block 1 here, block 1 here. Again block 2 here, block 2 here, block 2 here, block 3 here, block 3 here, block 3 here, block 4 here, block 4 here, block 4 here. Again block 5 here, block 5 here, and block 5. Yes, this cluster is a distributed system. Block 5 here. Basically when we say cluster, cluster actually means the combination of many systems. Okay, now what we have done is we have distributed all the blocks with the replication 3, and you will see that each block is repeated 3 times, right? Is copied in 3 different locations, and of course that will be maintained by your data node only. Now assume that you gave your MapReduce program. Okay, you have written the MapReduce program, converted them into a jar file, and you submitted your job by using in form of my word count.jar. Now it goes to, this goes to job tracker, right? Job tracker will then try to send the data to all the task tracker. Sorry, it will not send the data. The job tracker will try to send the jar file to all the task tracker. To all the task tracker, and then the task tracker will forward that to whom? The task tracker will forward that to whom? Not data node. Data node will only maintain the data, will forward it to, just now we discussed one more process, task tracker to, yes, task instance. It will forward it to task instance. So in the task instance, by default how many map slot, how many reduce slot? 2 each. Okay, so in this node how many blocks you have? In this node how many blocks we have? 4 blocks. Block 1, block 2, block 4, block 5. So out of these 4, okay, it will be able to process only 2 blocks at the same time, because we have only 2 map slots. Are you getting it? Okay, so in a typical very large cluster, if you have, let's say, 1 GB of data, so 1 GB of data will make around 12 blocks. 12 blocks, let's say 12 blocks, more than 12, around 15 blocks. So at that point here you will get lot of blocks. You may get here 10 blocks. So even though you have 10 blocks here, how many blocks can be processed at the same time? Only 2. Okay, and what about the remaining blocks? When will it be processed? Later. Okay, they have to wait. So here, since our data is very small, 300 MB, okay, and it is all distributed here, so the job tracker will guide all the task tracker to process which block. Okay, so it may happen like this. I'll tell you, the job tracker will tell this task tracker to process only block 1. Okay, it may ask this node to process only block 3. It may ask this node to process only block 2. It may ask this node to process block 5. What is left? Block 4 is left. Now it may ask any other system to process block 4. Maybe this one. Is not it? So with this scenario, okay, do we need to wait for like does any block has to wait for its turn, or will it be processed parallelly? Question is, with this scenario, will a situation come that a block has to wait for its turn, or everything will be processed parallelly? Come on. Parallelly, because we have 2 slots ready and we are not processing any 3 blocks here at the same time, right? We already have 2 blocks. Sorry, we already have 2 slots, 2 map slots we have, so we can process it without waiting. Let's talk about something big. Okay, let's talk about something big. Let's assume we have 2 GB of data. Okay, with the block size 64 MB. So it will be divided into how many parts? 2 GB means 1024 into 2 GB by 64, 32. Okay, that means 32 blocks, is not it? Now let's assume that the replication factor is 1 only. For easy understanding, let's assume the replication factor is only 1. So if replication factor is only 1, then how many blocks will be stored in each system? Yes, we have 2 GB of data with 64 MB block size, and total block formed was 32, and we have 4 nodes. So how many block will be stored in each node? 8, right? We are just talking about the general mathematics. So 8. So block 1 to block 8, let's assume only. Okay, there is no guarantee that it has to be stored very serially. Block 9 to block 16, block 17 to block 24, block 25 to block 32. Okay, now all these nodes has map slot. How many map slot we have for each node? 2. But how many block it has to process in each node? 8 nodes, right? In each node we have to process 8 blocks. So don't you think here they have to wait? Okay, so that is what I wanted to conclude, that uh, it is not the task tracker who actually does your job, but it is the task instance. Alright, the task instance is created by task tracker. And why they have these two things, task tracker as well as task instance? Reason is very simple. Let's assume that you have written a piece of code and this is a whole cluster. Okay, in this whole cluster, can you tell me how many name nodes will be present in the whole cluster? How many name nodes are present in this whole cluster? Okay, one. How many job trackers are present in this whole cluster? One. How many task tracker are present in this whole cluster? Four. How many data nodes are present in this whole cluster? Four. So let's assume that you have written a Java program, okay, which contains some bug. You are a junior developer and you wrote some code which has got some bug, due to which, okay, and you have submitted that job. So the job tracker will transfer this word count.jar to all the nodes, is not it? And then parallel processing will take place in all the nodes. Okay, your Java code will be executed in all the nodes, right? And let's say that the task tracker actually takes care of processing. Let's assume the task tracker is actually taking care of processing. So what will happen? Your code has got some bugs, due to which one or other exception you will get, and the JVM will die or not. Now, if the task tracker dies, the task tracker will die here, the task tracker will die here also, the task tracker will die here, the task tracker will die here. So what will happen? Your whole Hadoop system will go down, is not it? Right? And moreover, do you think you will be the only person who will be using this Hadoop cluster, the production one? There will be many teams, okay, they might have written a lot of MapReduce program, their jobs are also processing, and you wrote your program, and due to your program you have killed all the task trackers. So what will happen? Your work will be impacted, as well as their work will also be impacted, right? So you may have a question, why will I put my buggy code in the production? I will use it locally, I agree that, but don't assume that the production systems are not are purely bug free, because there are instances where we may find later, we may realize, okay, due to some reason it is not working properly in the production. It may happen. So that is the main reason the task tracker is actually not involved in processing the data. Clear? It is a very very important interview question. What is the responsibility of job tracker? What is the responsibility of task tracker? If they ask you this, you say job tracker is the master, okay, which will monitor all the task trackers, and it will assign all the work to task tracker. And what this task tracker will do? The task tracker will again create a separate JVM called task instance, and it will assign the work to the task instance. So the actual work is not done by task tracker, the actual work is done by task instance. In the task instance we have two things, one is map slot and one is reduce slot. In the map slot, all the mapping activity will be taken place, will be done. In the reduce slot, all the reduce activity will be done. And once that is completed, it will give response to task tracker. The task tracker gives response to job tracker. And frequently, the task tracker will send some heartbeat to job tracker. Similarly, your data node will also send the signal to name node. Okay, just to tell that I am still alive. Are you clear on this? Okay, now the idea is the main work is done by your task instance, and task instance is a separate JVM. Even if the task instance gets killed or uh, gets shut down due to one or other activity, no problem, our task tracker will still be safe.